Hi, in this video we're going to see how to integrate basic functions. So far we talked about power laws, and the first example I want actually to talk to you about here, it's the power n equal minus 1. I'm talking about a function that looks like x to the power of minus 1, or if you want, 1 over x. Now we have to ask ourselves, what is the antiderivative of 1 over x? So what I want to ask is, what's the integral of 1 over x in dx? What is the function that derived gives me 1 over x? If you remember from differential calculus, the function we are looking at, it's actually the natural logarithm. So we're looking at the function f of x, capital F of x actually, that it's equal to ln of x. If I take in fact the derivative of f of x, I find 1 over x. So it seems here that I am perfectly fine in writing ln of x plus a constant k, where k is real. Now the problem here lies on the fact that the natural logarithm is a function that is only defined for positive x's. So if you remember, if this is the function, the domain of this function, it's actually x belonging to R, such that x is larger than 0. And this is a problem because it means that this function is only defined in this particular domain. So what happens when I integrate and I actually take negative x's? Well, there is somehow a trick for that. So let's first write what we learned so far, so that the integral of 1 over x in dx, it's actually equal, we said, to ln of x plus a constant k, and this is valid for x larger than 0. Now, in the case of x less than 0, what we can do is to define another function that is g of x, which is going to be ln of minus x, which is now defined for x less than 0. This provides a function where the argument here is always positive, because minus a negative number is a positive number. So I am defining actually a function g of x that can be derived. So now, if I derive this function, so I take the derivative with respect of x of ln of minus x, I'm going to get the derivative of ln first. Here I'm using the chain rule, so I have 1 over minus x times the derivative of the inner function, minus x, which is minus 1. And therefore I get the derivative, which is 1 over x, which is exactly what I want because it's the integrand, 1 divided by x. So I'm discovering that the integral of 1 over x in dx, it's equal to ln of minus x, which is found over here, plus a constant k prime, for x that is less than 0. So what I find is that, number one, I have that this integral, let me write it like that, it's equal to ln of x plus a certain constant for x larger than 0, and I'm discovering that it's ln of minus x plus a generic other constant for x less than 0. And therefore I can rewrite all this as the integral of 1 over x in dx as in fact the natural logarithm of the absolute value of x plus a generic constant c, where c belongs to the real numbers.